Hey guys, today we're going to discuss this problem. It's a 1900 problem, and as always, we're going to start with the example here. So before we explain the example, I would like to explain three terminologies. The first one is permutation of an array. So this is an array with three items, right? If you reorder these items, and each of the new array will be a new permutation of that array. For example, we can put the array in the order of 4, 3, 5. So this is one permutation, right? And 5, 4, 3 will be another permutation, etc. And item-wise smaller, what is item-wise smaller? So if we have two array, like 2, 2, 5, and 1, 1, 4. So if each of the items of one array is small or equal than the other uh, item in the other array in the same place, then we call this array is item-wise smaller than this array because 1 is smaller than 2, 1 is smaller than 2, 4 is smaller than 5. So we call this array is item-wise smaller. All right. If we change one of the items, change this guy into 4, then 4 is bigger than 2, so we cannot call this array is item-wise smaller than this array, right? So the last one is fx. So to calculate fx, fx is a boolean. And to calculate fx, we are going to create an array first. This array will start with x, right? For example, if we are going to calculate fx, f3, for example, we're going to create an array started with x, which is 3. And the following items will be 1 bigger than the previous one, which is 4, and the following one will be 5. So we are going to create 3 numbers, and this array will have 3 numbers, right? And then we are going to find the number of permutations of the given array that is item-wise smaller than the target array. So in this case, this is the only permutation that is item-wise smaller than the target array, right? So the number of permutations is 1. And we are going to check if 1 is divisible by p. So p is this number, right? N is this number. So we are going to check if 1 mod 2 equals to 0. If it is not equal to 0, then this x is good, right? So let's take this example here. So if x is smaller than 2, which let's take 2 as an example, we're going to have the target array like this, 2, 3, 4. There are no valid permutation. So because 3, 4, no matter how we change the order of 3, 4, 5, this array cannot be item-wise smaller than the target array, right? So fx equals to 0 for all x smaller than 2, right? The number 0 is divisible by 2. So all integers x smaller than 2 are not good. So this integer is not good because fx equals to 0. Forgive me, I previously said that fx is a Boolean, but actually fx is a number, the number of itemwise smaller permutations. So we are going to remove this phrase, right? And if fx is divisible by p, then x is not a good number. If it is not divided by p, x is a good number, right? So how do we solve this problem? So we are not going to have a very big n here. So the maximum for n is 2000. So the solution of with the complexity of n squared is good enough, right? With that being said, we can just iterate all of the x from 0 to 2000. We check each x, right? And check if fx is divisible by p. So how do we calculate fx? That's a problem here, right? Let's take an example here. Let's say we're going to calculate f3 for this array, right? So the target array will be 3, 4, 5, 6. And how can we find the number of permutations of this array that is item-wise smaller? So in this case, we are going to imagine 4 blanks here. And we are going to put these 4 numbers into these blanks, right? First, we are going to put the biggest number, 6. So where can we put this number, right? So we can put the number here, right? Because this guy should be item-wise smaller than this guy. So it should be small equal than this guy. Can we put it here? No, because if we put it here, then this array is no longer item-wise smaller, right? So this place is the best we can do. So we can find the pattern here. Let's say if we can put a number here, then we can also put that number here, or even to the right of the array, if there is, right? And in this case, this place is the best we can do for 6. So the number, let's say we're going to calculate the number of permutations. So the initial value is 1. And now we have 1 option for the biggest number, 6. So we are going to multiply the initial value by 1. And how many options for 5 here? Still 1 option, because the number bigger than 5 is already take 1 slot, right? So 5 initially have 2 options, but the 6 already take 1. So 5 only have 1 option. So we multiply the number by 1, right? And we are going to check how many options does 3 have, right? 3 have 2 options. We can put it here, or we can put it here, right? So we are going to multiply by 2 here. And in the end, where can we put 2? So because 3, 5, 6 already take 3 slots, and there is going to only one slot for 2. So 2 only has one option. So we multiply it by 1 here. So the total number of permutations for this array that is item-wise smaller than this array equals to 2, right? And we check if 2 can divide it by 3. The answer is no. So we put 3 into the final answer, right? So let's take another example here, F4. And the target array will be 4, 5, 6, 7, right? And we also have 4 slots for all the numbers we have. And as always, we're going to find the place for 6. So 6 has 2 options, here and here, right? So we multiply it by 2. And 5 is going to have, initially is going to have 3 options, but 6 already taken 1. So 5 will only have 2 options, right? And for 3 is going to have 2 options as well, right? So we multiply by 2. So in the end, 2 will only have one option because there is only one slot left, right? So in the end, the final answer is 6. And then let's check if 6 is divided by 3, the answer is yes. Why is that? That is strange. My bad. So 2 multiplied by 2 multiplied by 2 equals 8. And 8 is not divided by 3, right? So we put 4 into the final answer, right? So that's it. Let's take a look at the code here. Let's zoom in a bit. So first, we are going to read the array we are going to have and sort the array in descending order, right? And we are going to check each x from 0 to 2000, right? And if the check returns true, then we put the answer into the final array, right? In the end, we are going to sort the final array and output it. So the key part is how do we check the x? So here we are going to have a function to check x. So we are going to put each of the items into those slots and find out, in this case, the item we have is so big that we cannot find a place for it, so we return false, right? That means fx equals to 0, means it is not a good number, right? And this case is that we can find a slot for the item. In that case, we are going to find how many possible slots do we have for that item. And then we are going to minus it by the number of slots that already taken, right? And check if that number is divisible by p, because in the end, our each factor we calculated will, if one of the factor is divisible by p, then it means the final answer is divisible by p, because p is a prime number, right? And if none of the factors are divisible by p, that means the final answer is not divisible by p. So we only need to check each of the factors is divisible or not, right? If it is divisible, then we return false. That meaning that it is not a good number, right? So that's it. That's how we solve this problem. So see you guys next time.